Time is now. Good morning, everyone. My name is Vlad Usatin, and this is my partner, Joel Hutchison. Today we will be talking about Tableau's data APIs. Before we go deep into the session, I would like, if you know how to code in any language, would you please raise your hand? Beautiful, thank you. I wasn't expecting that, but I'm pleasantly surprised. Now I'm going to pass it over to Joel to talk a little bit more about himself.
Thanks, Vlad. All right, so a little bit about myself. My name is Joel Hutchison. I'm a customer consultant with Tableau. I've been here 3.5 years, focusing primarily on the APIs that we have to offer. One of my passions is running. As you can see here, this is me running in Switzerland. I like to use the data that I collect from my runs, put that into Tableau, both visualize it and then analyze it and figure out where I can get better. I'm turn it back over to Vlad to introduce himself.
I've been working in technology pretty much my entire career, and my favorite things are hacking and security. So if by the end of the session you don't feel like there is no data left unconquered, please come talk to us.
All right, let's get into it. So our learning objectives for the day, first off, we're going to discuss each one of these data connectivity APIs in turn. I'm going to explain the different technologies that you might leverage when you're working with these APIs. We're going to compare the various data connectivity APIs and give you use cases for which one to use when. We're also going to demo a couple of these APIs for you live. I'm going to warn you the demos are focused around running examples because that's what I'm interested in, so I apologize for that up front. And then if we have time, we're going to dive into some other data connectivity options outside of the APIs. All right, so at Tableau, our mission is to help people see and understand their data. You've probably heard that. If you haven't heard it at this point in the week, you'll definitely hear it many more times throughout the week. Usually what that means is we deliver insights through a beautiful dashboard, something similar to what you're looking at right here. But a lot of times before the pretty dashboard, we have to connect to that data. And that's what we're really focused in on today. So what we're looking at is Tableau Desktop and the over 60+ different connectors that we offer out of the box. It's often the case, though, that something you may want to connect to isn't listed as one of those native connectors. So what do you do in those instances? Well, that's where these data connectivity APIs come into play. Back to you, Vlad.
So this session here is actually part of a group of sessions called Developer Track. Developer Track includes different groupings of APIs, such as automation integration. So these would be REST APIs, TSM APIs, auto deployment APIs. Then we have extensibility APIs. That's another bucket where you can add extensions into Tableau and enhance users' experience within the dashboard. Next bucket of APIs is advanced analytics. And this is something that's available today in Prep and Tableau Desktop, where you can make remote process calls in Python or R and get additional data or insights out of these services. Next bucket is embedding, where you will take Tableau and make it a part of your application, so you will embed it into yours. And then finally, we have this track, which is the data connectivity.
So because we're part of the dev track, somebody came up and gave us all these stickers that you can collect for a beanie. So if you're interested in those, please come see us at the end. All right, so we got through the required slides. Again, what we're going to focus on today is the Web Data Connector, the Hyper API, and the Connector SDK. So let's get into our first one. Oh, wait. No.
And then we have two bonus sections. So although there may not be official APIs that you can extend on your own, these are still APIs to get the data into Tableau for analysis. So that's the bonus section that we will show you at the end.
All right, so let's get into the web data connectors and what they are. So first off, I use this slide when I'm talking with my customers to explain web data connectors. The web data connector, or otherwise known as a WDC, sits in the middle there. And it's really a web application that's going to leverage HTML and JavaScript and make calls out to a web-based data source. So you can see a couple examples there. Obviously, this list is not exhaustive, but you see things like REST APIs. It could work with SOAP APIs. Fitbit, Strava, any of those web-based data sources that you're interested in getting data, you can design a WDC to go out, communicate with those services, bring back the data, and then what you'll do in the code, leveraging the API, is you're actually going to format it into a format that Tableau expects, a tabular format. And then these WDCs are accessible both through Tableau Desktop, and then they can be pushed to either server or online as well. Some considerations when working with WDCs. First off, at the bare minimum, you need to know JavaScript or HTML. You can leverage other languages as well, different frameworks. For instance, the example I'm going to show in a couple of minutes, I use Python Flask because that's the framework I'm most familiar with. Next up, you're going to have a web server. So you're going to have to host this web application on a web server. That web server shouldn't be on your Tableau server, just as best practices. It's not a technical limitation, it's just we don't recommend running anything else on your Tableau server. The next consideration is the data you're going to be accessing is coming over HTTP or HTTPS. And I put an asterisk there because if you do have server-side processing, you can actually make calls to non-HTTP or HTTPS data. Next up, what we're actually creating as part of this WDC is an extract. So at the end of the day, we're dealing with an extract when we think about WDCs. And then two final points if you're working with server or online. If you're on server, you will have to whitelist the WDCs ahead of time so your end users can actually work with them. And then if you're refreshing your data sources on Tableau Online, you'll use Tableau Bridge. All right, so let me jump over here into a demo real quick. All right, so this is Tableau Desktop that you guys are all probably familiar with. And we're just going to go to Connect to Data. And then down here we have Web Data Connector as an option. This opens up a window here, and we can see the recently connected to WDCs that we have. We can go ahead and select it. And then again, this is just a web application that I wrote to grab weather data. And the reason I'm doing that is because I wanted to try to, for my own purposes, I want to correlate my runs to the temperature and see if I run better in colder or warmer temperatures. So aside from being a web application, you can have the users interact with this WDC as we see here. So we can have a date range, you can have them provide credentials. I don't have an example where we're authenticating, but you could actually put that authentication right into your WDC and have a lot more interaction on this. It's very easy to share this with your customers or your people who are using your WDC. You simply share that URL with them. They'd be able to open it in their desktop. So we're going to go ahead and click, maybe we want to get a custom range of weather. I'm just going to say from the 7th to the 13th, and we'll hit apply. And go ahead and click that, and this is going to make an API call out to the Dark Sky API. And we'll go ahead and hit update, and it should bring us back basically the last week of weather there. So this is the weather for Las Vegas. I think I set it to 5 in the morning, but obviously if you had more options for your users to select, you could have them select what time they care about, whatever other options. All right, so let's dive back into the presentation. So that's WDCs. We're going to move over now and start talking a little bit about our next one, Hyper API. So the Hyper API is a script that you're going to write in one of the 4 languages we see there in the middle. So it could be Python, Java, C++, or a .NET language. That script, in turn, will go out to the data sources you care about and request data from those data sources. Return the data back to the script, and then the script is going to use the Hyper API to format that data into a format that Tableau accepts. You can actually create those .hyper files as part of this API. You can pair this API, the Hyper API, with our REST API that we talked about at the opening to actually publish those Hyper files you're creating directly up to your Tableau server or to Tableau Online. If you have multiple servers, you could publish it out to several different servers. So I want to step back and talk a little bit about the evolution of the Hyper API. So for those of you who have been working with Tableau for a couple of years now, you might remember the Tableau SDK. When I started 3.5 years ago, this is the API we had. It only worked with 3 languages back then, so you had Python, Java, and C++. And back then, we weren't working with Hyper files. We were actually working with what's called a TDE file, if you remember those, Tableau Data Extracts. And we had one simple function. We could insert into these TDEs and they had a single table inside each one of those extracts. Next, we released our Extract API 2.0, and this is really when we converted from the TDE over to our Hyper files. The languages stayed the same, but we also added in functionality that allows you to have multiple tables in an extract. And then finally, earlier this year, we released our Hyper API. We added, as you can see there, another language, the .NET languages. Most exciting for me, at least in this release, is we added SQL capabilities on top of this API. So now you have the ability to not only insert, but you can update, delete, and read from those Hyper files, making it more like a real database that you can interact with. Finally, we also have bulk insert, and I think Vlad likes this feature most of all, so he made me talk about it. I'm actually going to make you talk about it.
So the beauty of bulk insert, so for those of you who are familiar with some other leading databases, most databases of that category will have a bulk insert method where a database can read flat files off disk, specifically CSV files in this case, and because the database reads it directly without any code, the speeds are tremendous. So just to give you a little bit of flavor how much faster it could be, so traditionally you would iterate and loop row by row, keep inserting data. But when you do this bulk insert, the speed can be 10 to 20 times faster. So for example, so you know the Superstore that is a sample that comes with every Tableau installation. So one of my colleagues has taken that Superstore file and multiplied it to be millions and millions of rows. When we ran the bulk insert, we were able to do 1 million rows per second. So this is a significantly faster speed than it would have been doing iterating. So if you have large data sets and you already receive them as flat files, bulk insert is going to make things much, much faster during the extract creation phase.
All right, thank you, Vlad. All right, some other Hyper API considerations. So first off, you can connect to one or many different data sources and then bring that into a single Hyper file or separate tables within that extract. As I mentioned previously, you can also pair that with the REST API. So it's common to have a single script that's going to both use the Hyper API as well as the REST API in a single script. This final point is when you're working on collecting this Hyper data, you're probably going to want to schedule that. So this is externally scheduled from your Tableau server. What that means is Tableau server is not even aware of where this script is and cannot run it at this point. Maybe they'll change that in the future. But this means you'll probably schedule it with cron if you're on Linux or Windows Scheduler, if you're on Windows Server, or any other third-party scheduler you care to use. So let's compare these two different APIs. So on the left, we have our web data connectors. Both in the web data connectors and the Hyper API, they both result in an extract. So at the end of the day, you're still working with an extract regardless of which choice you make. They both have multiple table support. They both offer full and incremental refresh support as well. And here's where the differences come in. First off, a WDC can be scheduled inside of Tableau server. Whereas I just mentioned, the Hyper API is completely handled outside, so you're pushing data into your Tableau server. The next difference is there's a user interface with your WDCs, so if you want your end users to actually have a place where they can configure or scope down the data they're interested in, you would go the path of a WDC. The Hyper API, on the other hand, has no user interface for them to interact with. The WDCs are going to need, as we mentioned, a web server. You don't need a web server with our Hyper API. And then finally, the data sources, for the most part, that you want to access would be over HTTP or HTTPS for the WDCs. And on the Hyper side, you can access any data you want programmatically. All right, so let's quickly jump out of here. I'm going to upset Vlad because Vlad thinks this demo isn't very exciting. All right, so this is your Hyper API. It's basically a script that you would run or schedule from the command line. I'm going to run it real quick for you guys. What this is actually doing is this is grabbing what is called a fit file off of my Garmin watch and converting that data into a Hyper extract that I can then open up in Tableau. So as you all know, there's no Garmin fit file data source, but we're able to grab the data off the watch and read it into that Hyper file. So I told you it wasn't that bad to show them a command line. Let's go over here.
No booze.
So I also mentioned just a moment ago that for the Hyper API, you don't have a user interface. There's no reason you couldn't actually create a user interface on top of it. So this is just kind of breaking that rule I said just a moment ago. You actually could put a UI on top. It's just not required. All right, so let's jump over here, and we're going to go back into here. And we're going to open up that data that we just created. Give it a second. So here's all of the runs that I've completed recently. And this is more granular, so it has like, I think every 2 seconds it takes my latitude and longitude. All right, let's go back into our presentation. All right, I'm going to turn it over to Vlad, and he's going to talk about the Connector SDK now.
So Connector SDK is a kit to create new connectors. It's not specifically a new way to access data, but it's an easy way to share best practices or to sandbox a connector for your users. So the people or the groups of people that will be interested in Connector SDK the most would be people who own their system, so like Tableau partners. So if you already have developed a system and you want to provide a driver that is user-friendly and geared for your system, and you want to show up as such within Tableau, you would use the SDK. Or if you are part of the large enterprise where you don't want users to go ahead and use ODBC or JDBC drivers and configure all the possible options. You just want to give them something easy to use. This Connector SDK is for you. So what is really going on with Connector SDK? It's a wrapper around ODBC and JDBC. So ODBC and JDBC are two generic options offered with Tableau Desktop and Tableau Prep, where you can arbitrarily connect to any database that's hidden behind that connection. SDK will provide you samples. It will provide you, obviously, documentation. And for those who are not just prettifying and making a good user experience, but actually have special recommendations for Tableau, we actually bring a special harness that will go ahead and test your ODBC driver or JDBC driver and make sure it can support the analytical needs of Tableau users. When you're done configuring your connector, notice this is a new connection here. The dialog looks quite different from anything you have seen. So it's a two-part. So the login information or the user input looks traditional, but it can be fully controlled. The title is very special here. It's a two-part title. Part 1 is the name of the connector that you will choose. And then part 2 will be a special representative of who you are. So it will say name of the connector, and it will say by company. And one of the reasons is you don't want to confuse your users, or we don't want, as Tableau, have somebody else's drivers showing up as if they were official. So whenever you will use this SDK, it will have the name of your driver followed by the organization name that you have chosen for your connectors. Everything I'm telling you is available on our GitHub page under plugin SDK. So Tableau Connector SDK consists of files that define that connection and abstractions around this. These files control the UI's elements, so all the boxes like login, port, or anything that may be necessary. They have different databases. So even though there's only one SQL, but there are many different flavors of SQL, so this connector can actually choose the appropriate dialect of SQL that may be necessary for you. And it will pick the appropriate driver if you need it. And ultimately, these relationships are defined in 5 files that are expected to be part of this connector. In versions prior to 2019.4, which was just released, you would take these 5 files, which I'm about to show you behind the scenes, and you would place them in a specific directory. Starting 2019.4, you can compress, sign, digitally sign those files, and put them into what is called a TACO file, which stands for Tableau Connectors. So let's go and see what are these files that you need to create to provide your end users beautiful experience in connecting to data.
So Vlad, our dev teams are now using this connector for the connections we are building, right?
They absolutely are. So we have taken other drivers that you may have seen out there, and we have customized them using this framework, but it's all behind the scenes, so you wouldn't be able to tell it. But we are using this framework as a native design tool for our connectors. But when they're deployed as part of the product without the techniques that I'm about to show you. So it's transparent, but they are still used by our teams as well.
If you guys use the MariaDB, and you've noticed that in our list of connectors, that was built out using this SDK.
Yep. So let's begin. So like with most packaged, whether they're drivers or it's a very common technique in developer world, is to provide a manifest file. So you can think of it as an initial file or a bootstrap file where everything begins. So for Tableau SDK, it is called the manifest.xml. So first things I want to point your attention to is the naming. So when I showed you that screenshot of a connector, so first the first part is the name of the connector. So in this case, it says PostgreSQL.JDBC. This is the one I'm going to be writing it. Then the company name, and it says by company name. So if you want to put your company name, so Acme Corp, you would put Acme Corp here. So when this SDK driver is loaded, it will say PostgreSQL.JDBC by Acme Corp or company name here. So that's one, basically defining the name. Next, you would pick what drivers you are inheriting from. So there's always necessity to have a underlying JDBC, ODBC, or maybe one of our native connectors that we already have that you want to customize. So let's say Greenplum, you can go ahead and kind of extend Greenplum further. You don't need to start from scratch. Then we have another convenience. So how many of you have used TDC files before? All right, not too many. So a TDC file is a file to customize any Tableau connection. So for example, some connectors will go ahead and create temporary tables in your database to speed up analytics. Others may do impersonation or fire parallel queries. Some will fire 10 parallel queries, others will fire 1 parallel query. So there's always reasons to create these fine-tuned customizations, and that existed all along. So a user in prior versions of Tableau where connector SDK was not available would create a file that would have these flags. So if you see the section here, cap select into, they would customize their drivers and provide that TDC file to all their users. They would have to put it on the server. They would have to email that file around. So now that file has been brought into the fold of the SDK, and that's part of your manifest definition, where you can provide best practices for your connection. Next, you will see links here to additional files that define your connector. So we have a connection resolver. So this one will choose further in which driver we are enhancing. So in this case, it's a JDBC driver. It will point us to a JavaScript file. So there is another file which I'm introducing you to, which is going to build a connection string. So to connect to a JDBC or ODBC, there's always this long string that you have to build. And you build it out of passwords, ports, and so on, which you see defined further down in this line. Next file we have is connection dialog. So if you recall, I showed you a picture of a traditional dialog. A connection dialog will usually have a server name, port, user ID, maybe security token. Maybe it will have a secondary. So if you have a failover in your driver, maybe it'll have a secondary DNS or IP address. So it's a bunch of data entry text boxes that usually users, when they inherit your ODBC and JDBC driver raw, they would have to go ahead and know what port to put in and so on. So what you can do in this file, you can define, first of all, what you show to your user, or maybe what you don't show to your user. So you can theoretically, especially for people who run tight governance, secure environments, and do want to allow users to connect directly to their databases, you will create a connector that hides some of these important details, like they don't need to know what port they're going to. Maybe they don't even need to enter a server name because you're going to package it in because that's a requirement within your organization that no one needs to know. All they need to know is just use this driver and it knows what to do. So in this connection dialog, you will choose how much information to let your users enter during the connection phase of your connector. Next, we have a dialect. So dialect, so as I mentioned earlier, not all data, even though most databases speak SQL, not all SQL is the same. And in here, we provide various base classes. So there's the ultimate base class, which is the ANSI standard SQL. Then other databases like Microsoft SQL Server, Postgres, Oracle, they have their TSQL, PLSQL, PostgreSQL. We have done all these for you. So if there's a driver already on our list that implements the dialect of SQL that your ODBC or JDBC driver is using, you will tell here, this is the dialect that my driver speaks. And then you can go even further. So some databases do not. So in this example, you could see that there is no float data type in Postgres. So what it does, it actually converts floats to reals, and it provides the cast function in Postgres to do that. So again, you can go ahead in this dialect TDD. You can not only tell Tableau what is the SQL that we're going to be writing, what's the flavor of the SQL we're going to be writing on the fly, but also to provide dynamic replacements for some of the functions that may not exist in the original language. Finally, once all the UI elements have come through, the dialect has been chosen, and the user has entered whatever information is necessary, there's going to be a JavaScript logic executed that is going to build that connection string. So obviously, you're going to be collecting some information from your config files, from the user input, and then you can have some dynamic queries or dynamic insertions, maybe security context or security tokens, if so required, in this JavaScript code. So that's the connector SDK. Next part, now we're in the bonus section. So OData. How many people have heard of OData before? All right, good. I'm glad not a lot, because then it would be not so exciting. So OData is a standard, just like JDBC and ODBC. The standard is owned by a governing body called OASIS. OASIS is a famous group. As a matter of fact, I believe ISO has also just adopted them as a standard too. So OData is a standard just like JDBC and ODBC. What it is, it's defined to send rows and columns over HTTP channel, and specifically the pattern is called REST. The reason we're bringing it up, it is very common now that users are asking, hey, I have these REST APIs. Can Tableau connect to REST? And the answer is yes, we can. So OData is that interface. The reason you want to use OData is, number one, a lot of applications such as SAP, Microsoft SharePoint, Strava, they all have OData. So if you just look around or you purposely seek out OData, that interface may already exist. If you own your application today and you have homegrown APIs, it is trivial, very easy to take a framework from your language. So if it's .NET, it will be the OData framework from WCF. If it's Java, it will be the Java Spring containers. Or if you're coding in Python, there is There's OData for Python. So OData frameworks exist from scratch, or if they don't, you can write one easily because all it is, it's XML or JSON sent over HTTP channel in a predefined format that any OData understanding application can do. Just like JDBC and ODBC and Web Data Connector, it is a pull mechanism which could be scheduled on a server. In its current form, it can only do full refreshes. However, Tableau has recognized that there is demand for OData and RESTful services is trendy and people are asking for a lot. And we are investing in supporting the OData standard even further with ability to eventually do incremental refreshes. And today it's extract only, meaning you can do live connections and Tableau, but the standard itself supports live queries. So it really is very similar to JDBC or ODBC, but this one works on HTTP level, which means it can traverse firewalls through proxies or reverse proxies. And because it can go through proxies, that means you can audit the data payload. So if you have a security requirement to see who's querying what, are they querying too much data, is there something inside the data, OData standard will allow your proxy in the middle to provide additional oversight about the data that's flowing. Finally, there is no driver required. So if deployment is of a question for you, you can go ahead. There's no driver that needs to be packaged. It works across every single platform. So highly recommend when you have new data sources or you're trying to develop interfaces for Tableau to be used, try OData. One piece, so you may be probably wondering, so OData or Web Data Connector. So OData does not have any user interface. So there will be a query string, just a URL to your data, and then authentication method for it. If you want to provide a pretty user interface, Web Data Connector is your way to go. But if you're just looking for plain data pump, OData is a very, very easy way to get data out of your applications. And I would argue it's easier than Web Data Connector.
OData is one of Vlad's favorite topics.
One of my
if
favorite.
you haven't been able to tell. So if you do have new features that you're interested in with OData, please go out to our forums and upvote those. That would make Vlad very happy.
Absolutely. So here's just an example of what the dialog looks like. So all you do, you put in a URL that points to that server. If you were just to take that URL and paste it into your browser, depending on OData version, OData version 2.0, the content is encoded in XML. OData version 4 and higher, the payload can be also JSON. I personally don't care if it's XML or JSON. During compression, performance is equally good. The experience that you will have is slightly different than you will see from other connectors. So there is no way to do a multi-table joins, and there is no incremental refresh, and there's no live. But that's just for now. Once you begin upvoting that in community, and you will find personal uses for it, we're investing in it anyway. But your adoption will speed up getting all these things that I've just mentioned and get it to almost parity with JDBC and ODBC. So that was OData. Next part here is Tableau Prep. So starting Tableau Prep Builder or Tableau Prep in general, 2019.3 and higher, we have introduced a new element in the flows. The new element is called the script block. Script block is just what it sounds like. It's an ability to execute scripts just like you were doing in Tableau Desktop. So in Tableau Desktop, there are currently functions called script underscore, followed by the return type of it. That exact same construct has been implemented in Tableau Prep Builder 2019.3 and higher. So what that means is you can now bring in anything you want by writing a little bit of code, either in R or Python. So here's an example of code that would enhance or add additional columns. In this case, these columns are geolocation encoding of data that's being sent into that step. So what it will do, it will add the additional columns to you. So again, in this case, we are adding more data as columns. And that's one of the rules by working with script functions in Tableau. So you can't add new rows, you can add new columns. But what if you wanted to go ahead and use this script or this technique to get a completely brand new data set? How would you do it? So instead of writing this type of code where you use, so in here you will see we're using the data frame from Pandas library. What you would do, you wouldn't use any of this. So all you would use the Python or R for is to connect to whatever arbitrary service you need, and then you would create a CSV file and save it to your temporary space. Then the subsequent step that would be relying on the script will just pull the CSV file, and then you will go off with it. So this is how you would use it if you had to, instead of enhancing your flow by adding additional columns, you would want to just get a brand new set of data from somewhere. You would just write a little bit of Python code to create that CSV file, and then you will subsequently pick it up with just a CSV file data source.
All right, so I did want to highlight our developer program. If you haven't signed up for this, it is free to sign up for. You can see the link there at the bottom. You'll find out more about this as you go through the developer tracks. But what this gets you is it gets you a free development site. So I know a lot of organizations say we can't play with your beta versions because we're not allowed to run betas in-house. You could run our beta versions and get familiar with all of these APIs in your personalized development site that we give you as part of this program. You'll also get early access to all of our APIs, and you'll actually be able to talk to the engineers who are creating these APIs and ask them questions as they go through the development phase. So they have Scrum meetings. They'll actually invite you to those at the end of every month. You can see what they're working on and see how things are progressing. Finally, it's a great community. So if you are part of this, you have a lot of other people, a lot of organizations working on similar projects that can help you out with your project and what you guys are interested in. So when I have questions or I know the answer, I actually go out there and help other people out. And you actually get responses very, very fast, which is awesome. And if you haven't noticed the little dinosaur on the bottom, that's our mascot for the developer track. His name is Trex, so you can wake up the Trex inside each one of you.
I call him T-Rex. I don't know why I call him Trex. So as I've seen most of you developers, and you I hope you like reading docs. So everything we have, all from the SDK to Web Data Connector to Hyper API, we have a very good active presence on GitHub. Please go visit, subscribe, contribute. We have a developer tools site that is both educational and it provides you with new things that are coming out. So for example, if you visit developer tools link today, you will see that we have posted Tableau hooks. How many of you have heard of hooks?
Webhooks, yeah.
So an ability to execute external code when something happens in Tableau, and it was recently posted there. And if you like videos, YouTube, we have a channel where we post a lot of these exercises and hands-on coding examples in there. So please visit those sites to learn on your own and stay up to date.
So Vlad never lets me actually show the code, but we're good on time, and we're all friends here. So I'm going to bring up some code, and if it's all right with you, Vlad, of course.
Absolutely.
All right.
And
let's end the show here.
so we also have Q&A as well. Maybe you can do that with code, or you want to do both?
Whoa, we lost the screen. I think we can do both. All right, so I'm going to open up, he finished up by talking about Tableau Prep, so I'm going to open up Tableau Prep, and we're actually going to look at one of the flows in here that has a script, and I'll bring up the script as well. So the resolution is going to be a little bit crazy with this monitor, but let's see what we can get. All right, so first off, you'll notice I'm clicking on, of course, it's an example about running, but we're opening up a running flow, and it's going to prompt us right away about a warning. And it's because we're hooking up to that external service, which could be rserve or tabpy. It wants to let us know that there may be some risk of running the code that's part of this So we'll go ahead and say we trust it. And in here we have those activities that I've been downloading from my watch. I cleaned them up a little bit, but down, if you look towards the end here, we actually have a step called reverse geocode. So when we're setting this up, first off, you need to set up either tabpy or rserv, depending on which language you're working with. Tabpy for Python, rserv for R. Once you have that set up, you'll come up to server. Let me see, where is it up here? Settings and performance. Did I miss it?
It's here.
Oh, it's here. Sorry, that's how you do it in desktop. Right here in the settings, we pick which one we're going to work with, rserv or Tableau Python. You would connect, and then finally you need to browse for the underlying script that you're going to run. So in this case, we have a simple file called geo.py. And then the last piece that you would specify here is the function within that script that you want to call. Now if we come back in here, and let me open up. This is why you don't let me open up things, huh? All right, let's go to prep scripts. We're going to open up our GeoPy. So we talked about, or Vlad talked about, we do have pandas in here because we need to return a data frame back to Tableau. So at the end of this, Tableau is going to expect a data frame, and that's specified down here at the bottom. So here I have a function called getOutPutSchema, return a data frame, and I'm specifying not just the fields we care about, but also their data types. So you see we have prep string, prep date time, etc. Now above this is the other function that we actually refer to in prep, and this is the function that's going to be doing that reverse geocoding for me. So in this case, it's taking the lat long of my various runs, and it's converting using this reverse geocoder library and getting back for me the city, the state, and the country of where those lat longs were. So that's all there is to actually working with the tabpy and these scripts inside of Tableau Prep. All right, so we can turn it over to questions now. Let me jump back over here.